This one is like a fish. So drag drop your sum to here. In this sum is you see 2 pluses. So I need 3. So double click, plus, plus, plus. Actually, you look at the you look at that one. I have a minus, minus, plus, right? If you look at my green, so you can do minus, minus, plus. You see this fish have minus, minus, plus. Okay, just make it look good. I right mouse, flip. Flip this, okay? And so this is one of the minus. You wire it to one of the minus, okay? And now I'm going to build the second term. Second term is x, k divided by m. Group 3. Using group 3, okay. Do you see? Did I ask you? No. Okay. Do you see x? Do you? I need to build the second term. X multiply k divided by m. Km, that's constant. So I'm going to have a constant that multiply my x. So yes, I go here. Drag drop my constant, flip it and make it look good. Format, flip the block. Do you see the x? X is here. So use x, multiply this. And double click on this one. And this one is k1 divided by m1. Okay, and you wire this to one of the other minus. Okay, and the other one is a kv t. Kv, that's constant. And the t is a linear variable. That's the time. Okay? So you collapse your commonly used. We need to find out the t. T is a linear variable. So it's in the source. The source you see this ramp, that's your T. You drag the ramp, that's your T. And the T multiply a constant. Constant is a K, kV divided by m. Okay, so you go to your commonly used. You expand the commonly used. Drag, drop your. So this T, and this one, it's K. We call the K1. Okay. K1. Okay. Let's call it K. Let's call it K. Okay. Let's call it K. I'm going to double check all of them. Let's call it K. K. You need to have a multiplication. K multiply V divided by M everything connect to your plus. So let's double check this one. I'm gonna call the K, I'm not gonna call the K1. Okay. C, we can call the C, do not call the C1. And this one, you're gonna call this K and the C. M, you can call the M1, or and this one is K. Or let's remove all the one. So let's call the C, M, K. Okay. And I'm going to add a negative to inside. So do a negative here. This one, I'm going to do negative. So you put the negative inside, and for the sum, you're going to just do 3 pluses. It's the same thing, right? And now, you see the sum. This equals to your double dot. So you're going to wire this one to here, equals. Yes?
What do you have before the K times V and
K times V, that's for the external, so K times V divided by M. It's called M.
What's before that?
This one is this one is a T. I got this T from I collapsed this one. I go to source. So you expand the source, you get the linear ramp. This one, that's the T. T is your linear force. You can use this one if you want to use the clock. The clock is a T. It works same as this ramp. Okay. And so the sum, you see my green frame. You see the equal? So the sum equals to here. Let's save it. That pretty much complete your model. This red, we know MATLAB, what does red mean in MATLAB? It means error. Because those MC, those are not defined. Okay? So, so we are going to define those things in MATLAB. So go back to your MATLAB and go new script. This is your regular MATLAB script. We're going to write a program. Okay, new script. And save as. Save as in the same folder. And this one I call the submarine script. So the other one is called sim for simulink model. This one is code script. You cannot have 2 submarine. You cannot have them use the same name, even though they have different extension. That the other one, the sim model is SLX, and this one is .m. But MATLAB, if you give them the same name, they will not work. So we call them one sim, the other one called the script. Okay. CLC, CLEAR, We put those things in front. M equals to, what does M equals to? I'm gonna define those constants. M equals to 322, 0, multiply 0.031. 0.031. What do I do here? Mass in flux. You know what the percentage do, right? Give you the comment. Okay. And K equals to, no, K1. Okay. K1 equals to 1,000 divided by 0.6. And this one is the spring. The stiffness of cable. Cable 1. You said, no, your sim model you call the K. And here you call the K1. Later we're going to redefine it, so we call the K2. Now, group 4. Group 4. What did I do here in line 6? Who's in group 4? Okay. What did I do in line 6? I calculate the K1 and I assign that value to the K. Why do I do that? Because in the same model we call the K, we did not call the K1. Later I have another K2 or something. So I got the M, I got the K, I need a C, right? C equals to, what value do I get? 1,200. 1,200. Okay, here, give it a name. Design 1. This is design 1. Okay. C is the damping, viscosity. Viscosity, and this one is second feet. So this is the correct. And I name it. I save. No question, right? This is just define your constant. And let's run it. After I run it, these data will be posted in the workspace. So you change a folder, yes, you run it. And let's put a semicolon. So you put a semicolon, they will not show in your command window, right? And they only show it here. They only show it in workspace. Okay, so this is M. So we got those constant. Question? Good? Okay. Now, let's go back to your sim model. Sim model. We simulate in 10 seconds. Now, you run it. Did you get this error message? You click the run, sim model. You get an error message. Here it said V is not defined. You say, oh, that's right, I forgot my V, correct? What do? You're going to define your V equals lowercase v equals to 5 feet per second. You need to run it again. So you see your V here. And now you switch between MATLAB script and the sim model from here. You have two windows. This is the sim model. What happened? No error. Okay? No error. And now, we're going to add some monitor. This is your output, right? This is your output. So we want to see what my displacement looks like. So go to your commonly used. Commonly used block. You see the scope? That's the monitor. So drag this one to here. And this is called the scope. And you wire your X to the scope. And you call this is the X1 output. This is your X1 output. Okay? And good engineer, you monitor output, you always monitor your input. So get a scope. And who is your input? This one is your input. So connect this one to here. The KV divided by MT, that's your input. That's the external force. External force is your input. So name this one input. So X1, that's the displacement. Let's add more for your velocity. Add something to your acceleration. So this one connect to your velocity, and this one to your dot. And you name them, otherwise you get scope 1, 2, 3 for you get yourself totally confused. So this is X1 dot output. X1 dot, that's velocity output. And this one is X1 dot output. Okay, so double click on this one. This is your X1, and this is your velocity. If you do not like X dot, you call the V output. You can call the V1 output. You can call the V1 or X dot. And you do not call the dot, you call the A, acceleration, ACC, output. See, these are my output. Displacement, velocity, acceleration. And this one is my input. These are monitors, okay? You say, oh, nothing happened. Well, because you have not run it. So I'm going to run it. So, velocity curve, displacement curve, acceleration curve, and this one is the linear, your input. So for the system, the input is linear. Did you get this one? Here said run the system for 25 seconds. So what do? You go to your sim model, go 25 seconds. You save it, now you run it again. And so this is your displacement, velocity, acceleration, and this one is your input, 25 seconds. You see from 0 to 25 seconds. So that's how we solve equations using MATLAB. So this one, now let's see if we can answer questions. Okay, so this question I asked you, what's the maximum force in the towing cable? And when does it occur? Does the maximum force occur first, or the maximum acceleration occur first? And the elongation, maximum velocity. So pretty much here you have the acceleration, and you need to find the maximum acceleration. Okay, and now to get this, so looks like your maximum acceleration is 3.5, and the time that happened here, it's what time? It's probably 1 second or something like here. Okay. So that's this one. So you, as of now, you have two models. One is the mass, the red frame, the green, that's the sim model, and I have two files. One is for the simulink, the other one is for the other one is for the MATLAB code. So we completed this part. The rest of things we are going to do it next week, because you have a lab report to write today. So the rest of the time you can write your report. Make sure you save your MATLAB code, you save your sim model, this one. And next week we're going to